Back to programming. So where we left off, we were looking at for loops. Yeah. Which means we should now probably cover arrays, I think. So originally we were using, just make sure this is all on live, yeah, variables just to create storage locations for our values. So we've got integers, floats, and so on. But if we end up in a situation where, you know, we have loads of variables of the same data type, but say they're all associated with each other. So for example, this could be an ammo for a handgun or something, and let's say you've got like 15 shots and you want to have 15 of these, you know, pieces of ammo, and you very quickly you're going to create, you know, 15 integers for it. It's not really the most efficient way of doing things. If only there was a way to not write 15 of these and just write a big storage container to throw them all in. Well, never fear, ladies and gentlemen, because we can create an array. Ooh. So an array is a list of stuff, right? It's a storage variable where you can store multiple values of the same data type inside it. So instead of having ammo 1, 2, and 3, we can just have the 1, and then that contains all of them. Just pretty nifty. So how to do this, you would start off with the data type that you want. By the way, if this freezes in any way, it's because my laptop froze. We had a couple of issues last time, whatever. So let's say we're going to have an integer array. So we type in the data type we want. And to make this different from an ordinary variable, so to tell it that it's an array, we use the square brackets, like this. So instead of saying, okay, instead of just having one, we're going to make a storage or box of multiple. Righty. And then we give it a name, just as we did with variables. So let's say my first array. And then we could stop it with a semicolon to mean that we are just declaring it without any values. Let's get rid of this for loop. Let's just bring this down here. Just not focus on that for now. And because I mentioned it's a storage, you need to be able to tell it how many things to store inside it. So in the start method, we can do that. You can't do this, for example, how we did before. We have like 10, 11, you know, 2, and so on. You can't do it like that. You have to make a new block, like a new array. So you have to write new. So my first array was new, and then the data type that's associated with your array. So int in this case. And then we need to say, okay, how many slots is this array going to have? And just for simplicity, we've got 4 here. So we're going to say 4 as the maximum size of this array. So it's like allocated 4 new integer spaces. Okay, right. So now you've got this 1 instead of these 4. But let's say we want to, you know, add these in to our array. To do that, you need to be able to actually index the array itself, because there's no good you writing my first array and then trying to get the second position without actually knowing how to do that. So if you noticed before, when we created the array, we used these square brackets to mean, you know, it's going to be a storage container of something. And then when we made a new storage locations, we used the square brackets again. So that is the notation we use with arrays. So if we want to use, you know, access the very first element of an array, you would use the square brackets and inside put that position. Now in programming, in C in particular, the first position of an array is actually the 0th position, not the first. So if you wanted to get that first element, you would write 0. And then you're saying, okay, there could be something in here, or there might not be anything, and we need to set something into it. So when we first create 4 new slots, they're empty. You know, if you print it out, there's actually not going to be anything. So let's do that. Before we create anything, let's go ahead and print all 4 of those. So let's say my first array 0, and then we're going to do that 4 times, but for each successive index. So 0, 1, 2, 3. Now I've stopped at 3 because we have 4 slots in total, but we don't actually have a 4th index because arrays start at 0. So if it started at 1, it would be 1, 2, 3, 4. But because we start at 0, it is 0, 1, 2, 3, but there's still 4 elements there, if that makes sense. Okay, so I'm gonna get rid of all of this and save it and see what this prints out. So that they're integers, but we haven't set anything in yet, we've just created a new block of memory. So let's go back into Unity, let it recompile. If I go back to the console here and bring it up so you can see it, we're going to hit play and see what prints out. So 0, 0, 0, 0. Okay. So what could happen here, depending on your compiler, it may initialize a default value. If it doesn't, the thing it prints out would be some garbage value. Normally it's some sort of address, some sort of memory area where it is. But in this particular case with Unity, it's going to give it 0 as default so that it doesn't crash. But that's just something to be aware of. So let's change those zeros to something else. We want to actually fill it with something. So we could do it this way. We could say, okay, let's get the first element of this and let's set it to 10. Save it. Let's go back into Unity and then let's see what that prints out. So we just click play, and now we've got 10 in our first slot and 0, 0, 0 in the other 3. So we could follow suit with this, and for all of our subsequent pieces 1, 2 and 3, we can set these as something else. This could be a value of 1, this could be a value of 100, this one could be, I don't know, 44 or something. Now if we save that, let it recompile, and if we print that, it'll put it all, nice in order and stuff. So 10, 1, 100, 44. Kind of simple. So that saves you having to make 4 integers. You can just have one array of 4 elements, and that saves a lot of time. And not just time, but it's all neatly in one package. So you can always reference them, whenever you like, change their values and so on.